Hey guys, Dave the MMP. Back in my garage doing a little more work on the Pi 5 navigational enclosure. Okay, I'm going to do a little bit more work on the electrical enclosure for the Pi 5. I'm just stripping wires and using some stake-on connectors. That's what a stake-on connector looks like. This is a marine device. It's got a little heat shrink tube on it, so you shrink it, you crimp it, and then you use the heat to heat shrink it. It's got adhesive inside, and you can actually see the adhesive melt and run out. I tried to use those guys. I ended up having to use these guys because the terminal strip that I installed in the enclosure was too small for the eyes that I had. So you'll notice that these forks here, they actually have a little hook on the end of them. So I don't mind using forks. Normally I don't use forks because they can pull off or they get loose or whatever. These ones have a little hook on the end. They go underneath the screw and they can't pull off. So those are really good ones. The other thing I wanted to show you guys is a lot of people, they use just regular wire stripper. You can use these, they're okay. But nowadays, pretty much everybody's using an automatic wire stripper. Just insert the wire to the depth you want, hit it, it automatically strips for you. And the thing about it is it never cuts one of the strands, all right? So cutting a strand, you're reducing the capacity of your wire, and it's just not a good practice because if you use the wire stripper on the wrong size, you can break off, what, 6, 8 strands, and now you're really cutting down the capacity of your wire. So use the automatic stripper. The other thing that's a really good tool to use is a ratchet crimper. So you can hear it, and it won't release until you've gone down all the way. So you just insert it, crimp, and that sucker's never gonna pull off. These things are like 15 to 18 bucks now, 20 bucks, so there's no reason not to use them. And you get an absolute perfect crimp all the time. They actually put 2 crimps on, and it bends the middle of the wire up. So it kind of puts the wire in like a U shape, and it can't pull out, because it's kind of got like a speed bump on the inside of the crimp. These ones aren't heat shrink, they're just the regular ones, but I've got an enclosed enclosure and it's going to be watertight, so I'm not worried about corrosion inside the box. So I've got pretty much everything wired here. I got a little spot that I left open for the Pi, and going to do a little test and see what kind of heat I get in there. I got a lot of comments from viewers about how am I going to get rid of the heat? I don't really want to exchange the air in the enclosure. Originally, I was going to have this little fan here blow air in and out to get rid of the Pi heat. What I ended up doing instead was putting a little heat exchanger inside, and then I've got a heat exchanger on top. So it's a passive heat exchanger. The heat will transfer right through the box without exchanging air. If that doesn't work and I still can't get rid of the heat, I've got a little active heat exchanger with a fan. Now this is a special one for an NVMe drive, and it's got a heat pipe on it. So you can see the copper pipes, they're full of liquid, and they're meant to be sitting on the NVMe drive, but they're gonna made on my aluminum surface on top of the enclosure. There's a little spot of aluminum there from the inner heat exchanger, and I've sealed the whole thing with epoxy. So this guy will transfer the heat from the aluminum exchanger inside up the heat pipe, and the fan will get rid of the heat. So that's my active heat exchanger if I can't make the passive work, but I'm going to try it out. I've got a little recording sensor here, and it's a little temperature controller. It tells me the temperature and the moisture in the box. I don't really care about the moisture, but it's Bluetooth, so I can get it with my phone. So when I'm running the tests, I think what I'm going to do with you guys online is hook it up to a big monitor and let it run 4K video, and get the Pi to work pretty hard on probably Chrome or YouTube, and open multiple applications, get them running, maybe get Windy running at the same time, see if I can do that in a split screen. Hopefully I can max out the CPU on the Pi 5 and get it to reject some heat. It's got its own fan and its own heat exchanger for the Pi 5, so that's just going to move heat around in the box, and then hopefully my passive or active exchanger will get rid of all that heat. So let's take a look. All right, so here's what the enclosure looks like. Got my fan here, my cooling fan. Pi 5 is going to be sitting right here. Terminal strips here with all my wiring. I got a lot of comments about guys telling me to paint that DC converter, so I did, because it was just raw aluminum, so I painted it with paint. And same thing with the heat exchanger up top. So these heat exchangers got painted. The one inside I did not paint because it's never going to see any corrosion. I've got a little NVMe, which is a little heat pipe exchanger here. It's meant to be on an NVMe drive, and I've got aluminum, so you can see the exposed heat sinks on the inside. If I can't make the active or the passive coolers transmit the heat through the enclosure, then I'll end up using this little active guy. I've got a little Bluetooth recording device that tells me the temperature inside the box. So when I get the Pi in here and I start doing heat tests, I'll be able to read that with Bluetooth with my phone. This will be all enclosed, so you won't be able to see in it anymore. So this side's got all of my connectors. I got my fuse on the bottom, USBs, one's for my US puck, or my GPS puck. This is HDMI, and then just a little green light to tell me that the box has got power. On this side, my power will come in here. I got my converter. A lot of guys said put it on the outside, it's going to reject heat, so that's what I did. And originally I was going to put these aluminum fins on the front cover, but I thought it would make the front cover too heavy. So right now, all the heat's going to rise in the box. It's going to get caught by this heat exchanger, get transferred to these heat exchangers, and get rejected out of the box. So that's my plan for heat. Dave the MMP doing a little temperature tests on OpenCPN running behind me. I've got the enclosure all buttoned up. I'll show you what that looks like, and then we'll put the cover on and see what kind of temps I can get out of it. Okay, so it's booted up. Looks like it's about 18 degrees in here. It says 17 on the temperature sensor for my fan. And the Pi's running, but the fan's not running. So we'll see what happens when we button it up and start running some video. Alright, so Pi 5 is running, it's not running 4K video, it's running 1080p. And on this side I'm running Windy. And on the box I've got a little monitor here. So it's 27 degrees inside the box, 25 degrees in the room. And this is about when I started it, about 1 o'clock. It's now 4 o'clock, and it's kind of peaked out as high as the temperature's ever going to go. I did also query the CPU and see how hot the CPU was running, and it seems to have also kind of maxed out. CPU's maxed out at 55 degrees C, so it's definitely nowhere near throttling. So I think the cooling is a success. The box is just kind of barely, you can just barely feel it. It's a little warmer. So I really only have about a 2.5, maybe a 3 degree temperature rise from what's in the room. So I think my cooling is working just fine. All right, power consumption. So I'm powering this thing with a 12 volt battery right now. It's a lithium battery. It's got a BMS on it. You can see the power, it's at 13.28 volts. And the power is flashing between 0 and about 7 watts. It does have a recorder here, and the most amount of power that it's ever pulled was 9 watts when it booted. But right now it's kind of flashing between 0 and 7 every once in a while. I could run it off of this battery forever almost. Small solar panel would keep this thing running. The other thing I plan on doing is running my touch screen off the same power source, so then I might start to see a little bit of a power gain. All right, guys, that's it for me. Pi 5 is success, and next will be mounting it on the boat and getting the touchscreen going in the cockpit. Give me a like, subscribe, and I'll see you next week.